Hey, welcome again. And now we're going to look at the section 3 presentation language. As you can guess, in TLS we have different kind of messages that are specified in the specification. And before you can send them over the network, you of course need to translate them into bytes. And on the other side, you need to translate back these bytes into the messages that they are so that you can understand and interpret them. So we're going to see that. But instead of looking at this long section and trying to really understand what it's saying, I'm just going to take a look at different examples and show you how they are translated. So to do that, we can just, for example, take a client hello, and this is the client hello, and it looks like a structure. It looks like C if you're familiar with C. And this structure has different fields, and some have a default value or value that is set and you have to use it. And some of them have values that you need to set yourself. And depending on what you want to do, you'll set them to different values. And on the right here, I have this page, which is very, very useful. And we can actually look at what a client hello really looks like when translated into bytes. And you can see that it pretty much looks like that. Of course, this is hexadecimal, but you can understand that this thing is translated into this thing here. All right, so here, this thing is actually not too exact because we'll see much later, but a client hello message is not sent like that over the wire. It's first encapsulated inside a handshake message, which is encapsulated inside a TLS plaintext message, and then we can send it, kind of like TCP encapsulated inside an IP packet, and etc. TLS works the same way. So here we have the record header, which is not really part of the client hello message, but rather of the message encapsulating this one. So our real client hello starts here at the client version, which is 0303. As we can see, this is the legacy version, and it has to be 0303. And this value represents TLS 1.2. This is kind of weird, but this is how things are, because otherwise a lot of things would break, or this is rather what we observed. A lot of middle boxes and firewalls and implementations would break if given 0304 or something like that. So we just pretend that these messages are TLS 1.2 messages, and the real version is actually inside the extensions. So here what we have is the client version, right? And this is just what is protocol version. It's just a UIN16, so it's 2 bytes or 16 bits. And indeed we have 2 bytes here to write this value. Now what's next? We have the client random here. And actually I can open the annotation, that'll be easier. Client version is here. We have the client random after. So indeed, what is the random? It's a opaque value, so it just means a bunch of bytes. And actually, we know exactly how many. We have 32 bytes. And indeed, we have 32 bytes of randomness, which is needed for the protocol, just for different reasons that I'm not going to touch here. But really, in TLS 1.3, it's not really needed, but we're going to use it later for downgrade mitigations. So without telling you much about it, this is kind of useless value, kind of like this TLS 1.2 thing that we use for backward compatibility, but we can also use it for more clever stuff, and we'll see about that later. Here we have another legacy stuff, which is legacy station ID, and it's right here, and it's something different, right? We have this caret here, and this pretty much means that it can be 0 to 32 bytes, right? So you could have something that is of length 0 byte, or you could have the maximum value could be a 32 byte value, and this is pretty much what we have here. Since this is a value that can be of different length, we need to write the length of the legacy session ID field before writing the legacy session ID, And this is pretty much what this 20 here is. And 20 is the number, or 20 in hexadecimal is the number 32. And it means that what follows is 32 bytes of legacy session ID. If legacy session ID was nothing, was a value of length 0 bytes, then here we would have a 0. We would still have to write 0 on the wire, and then we would have nothing following it. And this is actually what the implementation tells you to do. If you don't really want to be compatible, you just set it to something which is 0, right? This field must be non-empty. Oh. A client which has a cache session ID set by pre-TLS. Okay, so this is TLS 1.2 or other versions kind of thing. But if we really care about TLS 1.3, we just set it as a 0 length vector. As I told you, you just write 0 and then nothing else. All right, so let's see the next field. And by the way, I got a bit slow here, and I guess get used to that. TLS 1.3 is filled with this kind of like small details and this kind of legacy field, and you need to set these to some values, and you need to check that they are set to some values, etc. It's very complicated. And if you want to write a correct implementation of TLS 1.3, there are many details that you need to get right. And this is why this video is not enough. You need to really, for every field, read the full description to understand exactly how to implement that. But here, of course, I'm just giving you an overview of how things are done. All right, so next we have cipher suites of type cipher suite, which is defined here. And it has to be 2 bytes minimum, because the minimum value of a cipher suite is an array of 2 U int 8, which is 1 byte, 8 bits. So it takes 16 bits, right, or 2 bytes. One cipher suite is 2 bytes. So here we have several ones, so we can have either 1, which is 2 bytes, or 4, which would be, 2 cipher suites would be 4 bytes, 3 cipher suites will be 6 bytes, and on, and we can have a maximum of this number. And this number is, see, they wrote that into this format to help us. This is something we can write. This length will be contained over 2 bytes, and so when we look at cipher suite here, we need to write the number of cipher suites that we have over 2 bytes, because this the maximum length will be contained in 2 bytes. Even though here we only have 3, which takes a length of 6 bytes, which we could have written on 1 byte only. Since the maximum value can take 2 bytes, we need to write it over 2 bytes. Right? I hope that's clear. So over 2 bytes, we write the number 6, and then we have 6 bytes. And to know exactly how to convert that back into a message, we just split them into elements of 2 bytes. So this is one cipher suite, this is another cipher suite, and this is another cipher suite. Here I have another opaque value, but you guessed how to write it. It fits, the length can fit over 1 byte, so here we just write the length and then the value. The value here is 0. So this is actually a value, right? It's not like it's empty, and it takes this length 1 byte. And here this one, extensions, is something that we write over the length needs 2 bytes to be written, so we first have the extension length over 2 bytes and then our extensions. And to know exactly how to write the extensions, you'll have to look at the extension field and to see exactly what you have to convert into bytes. So this should kind of give you an idea of how you translate this kind of structure into bytes. Maybe I can find another example. The server hello is pretty much the same. There is nothing really crazy here, and I guess every time you have an issue, you can take a look at this page to see how it works. One thing I want to mention is that you can look at Wireshark, and you'll have Wireshark ships with a TLS 1.3 decoder, so you can actually record a TLS 1.3 session and kind of look at how it behaves and look at exactly the messages are contained. See here, cipher suit length 004, so I have 2 cipher suits, and here I have my 2 cipher suits, 1302 and 1301. So Wireshark is very helpful, but here we're only going to look at this page since we're looking at simple examples. So extensions, okay, that's a good one. What is an extension? Every extension we have will be, so this is just one extension, will be an extension struct, which is an extension type that we have here. This extension type is written over 2 bytes, because it goes from 0 to this maximum value here. 0 meaning the server name extension, 1 meaning the max fragment length extension. And after and here we know exactly that this is over 2 bytes, so we can look at here, and you can see that if you want this to write the server name extension, you just write 00, the 2 byte 0, and you don't need to write the length because we know that it's always a length of 2 bytes. Right? These are not variable length values. What follows though is a variable length value that goes from either 0 to this value, which length you can write over 2 bytes. So what follows will be the actual length of the extension data, and then the extension data. So you have that here. The 0018 means that we have 24 bytes following, which will be the server name extension. And then you have the actual data, and to understand the in our particular example, the server name extension, you would have to look at how the server name extension is specified. And it will be specified with a structure very much like this one. And by the way, this way to specify these messages and these structures is very specific to TLS 1.3. It doesn't have a name, it's not ASN1, it's not C, it's not protobuf, it's none of that. It's just something that is specific to TLS 1.3 and is specified in that section 3 of the specification. So I don't believe that there are much more convoluted examples. Sometimes you will have these select and case. This pretty much means that in your supported versions structure, depending on what kind of message you're having this structure into, so this thing will appear in either client hello or server hello, it might contain something different. Right? So instead of specifying different supported versions for the client hello and the supported versions for the server hello, we just specify that as a large structure that has different cases. It's kind of weird. Sometimes you'll have actually different supported versions, one for the client hello, one for the server hello, but here we have a select and cases. So you'll have both in this specification. It's not very systemic. Yeah, I believe this is kind of everything you need to know, and I'm looking very quickly for a different example that I can find, but yeah, structure which is empty is just you don't write anything. So yeah, that should make sense. And if something doesn't make sense, well, just look at this page and try to figure out how it's translated. And I guess I'll see you for the next video, which is in section 4, and I encourage you to look at it next.